2-digit positive integer s is the sum of the 2-digit positive integers m and n. Is the unit digit of s less than the unit digit of m? So we have three numbers m, n, and s, where s is the sum of m and n, and the question is asking whether the unit digit of s is less than the unit digit of m or not. We have to answer this question in the form of either yes or no. Let's read the first statement, which says that the unit digit of s is less than the unit digit of n. So let's assume some unit digit of n. With some examples, we will try to understand how exactly things are changing about the unit digit. So I'm taking, for instance, the value of n as 25. Now the statement says the unit digit of s is less than the unit digit of n. So for n equal to 25, the s may have unit digit less than 5, which means either 4 or 3 or 2 or 1 or 0, right? So let's try to understand, if the unit digit here is 4, what should we add in this 25 such that the unit digit of the result comes 4? And the answer is you'll have to add 9 here, because 9 plus 5 becomes 14, and then the unit digit will be 4. And here there will be some other number. So we are not very concerned about the tens digit right now, because the question is only talking about the unit digit. So that's where my focus is. If we take the unit digit of n 5 and the unit digit of s as 3, so what should we add in 5 so that the unit digit results in 3? Then the answer is 8. You have to add 8. 8 plus 5 is 13. Similarly, to get 2, you have to add 7. 7 plus 5 is 12, which leaves unit digit 2. And what should we add in 25 so that the unit digit is 1? So now the answer is 6. And for 5, what should we add so that the unit digit is 0? Then the answer is 5. Now in this case, the question is the unit digit of s less than the unit digit of m? So in this particular case, unit digit of s is less than the unit digit of m. So the answer is yes. Unit digit of s is less than yes, 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 and yes. In every case, the unit digit of s is less than the unit digit of m. The answer is consistently yes. That means the first statement will be sufficient to answer the question. So with the instances, we are very comfortably able to answer the question, and the similar such example will be taken for the second statement. The tens digit of s is not equal to the sum of the tens digit of m and n. Now let's quickly see what happens. So we have m here, we have n here, and sum of them is also a 2-digit number s. Now s cannot exceed 99 because it's a 2-digit number. Let's quickly start taking some of the values of m and n, and let's assume that we want to keep this number as 99, right? So there are several possibilities that we can see, that m can be 49 and can be 50. That's one possibility. But the statement says the tens digit of s is not equal to the sum of the tens digit of m and n. Here the problem is that sum of the tens digit of m and n is 9. So this does not meet the condition given in the second statement, so not an acceptable case. So let's quickly understand, when will the tens digit of s not be the sum of the tens digit of m and n? That's possible only and only if there is one carry forward going from this place. For example, if I take 45 here and if I take 46 here, the sum of the unit digits is greater than 9. And whenever the sum of the unit digits is greater than 9, one will go carry forward, and in that case, the tens digit of s will definitely not be the sum of the tens digit of m and n, because here 5 plus 6 is 11, so you put 1 here, 1 is carry forward, and we get 9, right? Similarly, we can take some other such cases, and our objective is that in this particular acceptable case, the unit digit of s has been less than the unit digit of m. So the answer to the question is yes. Now, in order to prove that the statement is not sufficient, I would like to increase the value of unit digit of s and would like to decrease the unit digit of m. So I'm taking another value, let's say 41. Then I can take here 49 for instance, and in that case 49 plus 1 becomes 10, 0, 90. And in that case, once again, the answer to the question has come yes, because the unit digit of s is still less than the unit digit of m. And the case is acceptable because the sum of the tens digit of m and n is not same as the tens digit of s. Let's take some more instances. What happens in those cases is that the unit digit, when we are adding the unit digit of these two numbers, for instance, if we are taking, let's say, 31 here and 48 here, then that's not possible, because in that case the unit digit is not summing up greater than 9, and we have to ensure that the unit digits are adding up to greater than 9. Not an acceptable case, because if that doesn't happen, then the sum of the tens digit of m and n will be the tens digit of s. So in that case, you will have to take some value of m here, and the unit digit of s is going to be even smaller than that. Let us take some other example. Let's say 44, and we are taking here, for instance, 47. See what happens. Again, the unit digit has come 1 and the number is 91. So there are several changes you can make, but always and always you are getting consistently answer yes. That means the second statement also is sufficient to answer the question, and the answer to the question becomes option D. Thank you so much for watching this video.